Hello everyone, welcome to my channel. Welcome to this third video of ADK from GCP. Today we are going to see the multi-agent architecture for an automated SRE system. Okay, so let's get started. I'm going to show you what system we are going to build today. So just have a look at this. Okay, so I have deployed my site on Netlify Grow and it is live for an hour, so we can just check the preview basically. So this is the dashboard which has AI triage SRE system. It has the sections like dashboards and alerts. Okay, and it has real-time monitoring, AI powered analysis and advanced analytics basically. Okay, so what it does is if we open the dashboard, we can see this is the admin dashboard. These are the AI agents. The 6 agents basically, each are responsible for doing a specific job in an automated way in a very less time, and these are the recent workflows and the system metrics. Okay, so admin dashboard uh, basically has a mission control for our SRE operations. Okay, so at the top we can see that these are the key metrics. 99% alerts processed today with a 94.7% success rates and averaging just 1.2 seconds per workflow. So below that we have these 6 specialized agents, each handling a specific task. Notice that all these agents are showing the healthy status with uptime about 99% almost. So this on the left you can see that recent workflows in real time. The payment processing errors was analyzed, resolved in just 5.3 seconds. On the right, you can see the system metrics, which shows the resource utilization. Basically, everything is running smoothly. And if we navigate to the alerts section, what we can see here is um, the incoming alerts from a monitoring system. So if the alerts are with high priority, severity, medium and low severities, the sources we can decide, the teams, Microsoft Teams basically, or maybe Genius monitoring systems. There is one from Teams and the other one from Genius with a failed workflow status and high severity. So we can filter this by this particular filters for severity and um, the sources. So we notice that this payment processing error from 5 minutes ago, this workflow is already completed. Let's check the details to see the what was the error. So action is if we click here, we can see this the source and all, and run book, which we have to process the run book, check the troubleshooting steps, check the payment gateway connectivity, verify database connections, review error logs for request IDs or trace IDs, check for service degradations, and analysis results will give us the root cause analysis. Payment gateway connection pool exhausted. This is the conclusion that it has drawn. It has given us the impact high, 15% of payment transactions. Then the recommended actions, it will give us increase connection pool size to 50, enable connections, pool monitoring, consider implementing circuit breaker patterns, or review slow payment queries. So this is the alerts analysis that this agent has done within less than 10 seconds, and it has given us the complete analysis. Okay, so the next part here, what the AI triage we do here is the alert comes from the Microsoft Teams with high severity. Our system fetches the relevant runbook, and then Gemini AI model processes the analysis of the errors and determines the root cause. Okay, so here Gemini AI will be used. So the impact is high and recommended actions. Everything will be processed by the Gemini AI intelligence, and it's flagged as escalation to the on-call engineers or whoever is responsible for maintaining the site. So all this happened automatically within just 10 seconds. So um, what we can say in the analytics dashboard is that it gives us a deeper insight. Basically, the line chart shows alert volume over the last 24 hours. We can see a spike at noon, and which should be having an investigation. The success rate is holding steady at 94.7%. That is 142 successful requests versus the 8 failures. Looking at the error types, we can say that payment errors are the most common at 30%, followed by database errors, timeouts. This tells us that where to focus our infrastructure improvements on basically. And in agent performance shows the analytics agent is slowest, like at 2.1 seconds, and which makes sense since it's the Gemini AI model. So everything else is in the sub-seconds. Okay, and let me show you how this works under the hood. So we can have a complete architecture diagram to view the entire system. I hope this system was clear to you. This is my GCB project. Okay, I'll show you my GitHub repository. Yes, so this is my GitHub repository. I have compiled all the source code in different folders. I'll walk you through each of them and how we have used tech stack as Python, GCP services, Vertex AI, Google Cloud Run, and everything for deployment. So this is the GitHub Actions workflows for continuous integrations and continuous deployments. Um, Through the Terraform provisioning. Okay, so enterprise grade CI/CD setups we have put here with workload identity federations for keyless authentications. We don't have a need to put our tokens or API keys or secrets. We will use the keyless authentication using workload identity providers for authenticating this service account using this feature of GCP. Okay, so we have different workflows for deploying this end-to-end deployment using this YAML file. Okay, this will have the apply feature for Terraform apply. It will use the sentinel policy checks, and further it will plan and apply. Next will be the planning. I mean, before apply there will be a planning workflow which we can execute for any of the agents and check our Terraform plan. And this is the build and deploy agents, so we can anytime build Docker images and deploy the agents using this workflow. Okay, here everything will be stored like the artifactory path, the image storage locations, and the latest tags of the images from where to pull it. Okay, so this is CI/CD part. These are the ADK agents. So basically, these five agents and one root orchestrator agent, which will overall orchestrate all these five agents. This first alert ingestion agent is having this requirement Google ADK, and we have written this in the Python. So here we are importing the logging, and from Google from agent we are importing the google.adk kit. So logging is the basic feature, and the class that we are using here is defining the function for initializing this agent. The normalized severity ID, everything is passed using the APIs, source as APIs, and then the status is returned as alert is normalized, or and the status is returned as ingested. So once the alert is ingested, the other agent will be revoked. Basically, the output of first will be fed to the input of next. So here, LangChain Google Vertex AI is the package that we are going to import from Python, like from Vertex AI, and defining these functions for initializing the analysis agent with Gemini. Okay, and then it will return recommended actions like restart the database or scale up the instance and all. The next agent will be for Confluence, and it will have this particular requirements and dependencies. Will import these libraries, LangChain basically, and Vertex AI, Google ADK. And logging is a mandatory thing because this is a SRE system, so we are all the time importing Google logging. And the self vector store, if else condition, will route the decisions of this model. So where to route, on which agent, or whether to proceed or not, this will be decided with this if else logic. And then the results will be returned like found runbook query, then go to this action and restart the service if the status is success, and we'll check with the mock confluences. And main will return the confluence agent, return the output to the confluence agent. So confluence agent will return this entire output to the postgres agent, the database agent basically, which is responsible for analyzing the entire database query. It will log in using the connection strings and patterns that we are going to give for its host name and connection name, uh, basically. And then the root orchestrator agent, this agent will orchestrate the entire flow of the system. Okay, so here that's how the ADK agents are developed in Python. Here we can also use the Python notebooks. In Python notebooks, as we can see, we if once we log in, we have a different utilities like the terminals, VS codes, PyKernels available. So whichever is feasible for us, we can use the .ipynb notebook files and develop our Python code in that notebooks as well, and proceed with the testing of the Python code. So once everything is tested, you have all your notebooks developed. So instead of this like ADK agents 5 folders, we can create 5 notebooks dot ipynb files, and sixth file will be for deploying the uh, entire Docker image of this and all these agents together to maybe GKE cluster or Cloud Run or whichever service you feel is feasible. So you can deploy that. So that is how the entire deployment can happen for this project. So I right now I haven't deployed all this on GCP because these services are, I don't want to keep it on for a longer time, so I have deployed it not locally. Also I have deployed it on Edify, so I'm using those deployment servers for showing as a demo to you. Okay, and basically, if you have to check the documentations, I have the detailed documentations for entire setup, the workflow workload identity federation setup, how we export the variables, and how we create the JSON keyless authentications for GitHub. That I have written here. How we grant the permissions, and all these things we have put. How to put the GCP project ID, the bucket ID, how to store the state files. Everything is mentioned in this document. This is the setup document in which entire prerequisites, what needs to be installed first: Docker, Python, Terraform, Google Cloud SDK, Git, Jupyter Notebooks. Okay, and if they are provisioned to you, then you can use that as well. The GCP requirements are Firestore database, Vertex CI API should be enabled, secret managers should be enabled, 5.7 cloud run services will be there. So these API quotas will contribute to this much. Okay, and we should have basically owner editor role on the project. External systems that we can use are Microsoft Teams. We can integrate using the webhook URL, the Confluence API token and base URL. So that is how we can integrate Confluence with the agents. Postgres database connection details we can give. Secondary database connection details also we can give. So firstly, we'll clone our repo, set up the Python environment, configure the GCP project, run initial setup using the scripts. I have the scripts folder as well here. This sh shell scripts will set up the GCP, set up WIF, deploy agents, configure secrets. Okay, and then one by one we'll run these scripts and then deploy the entire infrastructure. We'll initialize the Terraform, review, plan, and apply. Okay, so application deployment will happen with built container images that we are going to store on the Artifactory. Okay, manual build and deploy can also happen. We can do it manually as well, but we can do it through the CI/CD, as I have already written the deploy.yaml file. Okay, this is the entire CI/CD setup here, and how we can test with Jupyter notebooks. How we can test with Jupyter notebooks is we'll navigate to that folder ipynb first notebook suppose, and then write our entire code there, send a test alert and check to Firestore, Google Cloud Firestore database list project, and project ID pass the variable. Okay, these monitoring logs we can check using Google Cloud logging read services, view logs, dashboards, troubleshooting, and issues that we can check with different flows like secrets not found or GitHub actions not found. We can check in the notebook itself. In the notebook cells, we can write this and test, run it. That block will give you the result if it is having an issue or it is successful. You will get to know it there to there. That is the advantage of using Jupyter notebooks. Okay, and this is a checklist what we need to do, what is the next step. Okay, and the complete project documentation also I have provided here, in which this is the base architecture diagram. So as I explained you, monitoring systems like Teams or Genius will feed the alert through a webhook URL to the first agent. It receives and normalizes the alerts, this agent. Then the output is fed to the root orchestrator. Here it will validate the alert using the Confluence, and the runbook is fetched. Then the query is inserted into a database, not inserted, basically executed in that database. It will not have any write access to avoid any issues with the production systems. It will only have read access and analyze the errors. Notify agents will notify and everything will be stored in the Firestore database workflow state. So that will be fed to the front end dashboards for analytics, alerts, and admin dashboard views. Okay, so this is the component, each component breakdown details that I have given you, how to do the webhook integration for Teams, Genius, and where is the location, how to do it with the timestamp, and all these things are there in this document. Okay. And what are the sample queries that we can use, and what are the sample alerts that we can pass, scenarios basically to check for alerts to be successful on these um, agents. Okay. So so that is how we have designed this system, and I was happy that I was able to show you the demo for my application. And we will deploy more and more such complex agents architecture using ADK. This is a very interesting topic, and there are lots of scenarios still unexplored. So we try to find out use cases in our day-to-day lives and try to utilize Google Cloud's leverages these services like advanced services for ADK, machine learnings, and agentic AI era is there. So let's try to build more and more use cases and automate the flows. So I'm thankful for having this opportunity to showcase this, and very excited to implement this in the real world systems as well if I get an opportunity. So hopefully, stay tuned to watch the next video. We will have more complex architecture to showcase. And thank you guys. Thanks for watching. If you have any comments, you can provide those in the comment section. Thank you. Bye.